Hello friends and welcome to YouTube channel Freedom Tech. And friends, in last session we configure YOLO11 on our latest Raspberry Pi OS bookworm 64-bit version with Raspberry Pi 4 using Google Coral USB Accelerator. So in this session we will configure custom object detection on our Raspberry Pi 4 using latest Raspberry Pi OS bookworm 64-bit version. We will create our own object detection model for Google Coral USB. So before we move to our practical, friends, if you learned something from our videos, please consider to subscribe our channel. Okay friends, thank you so much and let's get started. So friends, as I mentioned in last session, we configure Google Coral USB Accelerator on our Raspberry Pi 4 with latest Raspberry Pi OS bookworm 64-bit version using Google Coral USB Accelerator. So in this session we will create our own custom object detection model for Google Coral USB Accelerator. So for that, simple, as I mentioned, first you need to configure the basic configuration for Google Coral USB Accelerator on bookworm 64-bit version. For that you have to watch the basic video. Simple, I have created a playlist. Watch a playlist and first connect the Coral USB Accelerator and configure the Google Coral USB Accelerator for basic configuration. Simple. So I have already done with basic configuration. Now simply we will open our programming, then Tony, and here it is. As you can see, this is what our last session virtual environment, which is a Freedom Tech folder, and we have here Python 3.9 for Google Coral USB Accelerator. Simple. So as I mentioned, this video is basically for the next part of our first video. Simple. So you have to first watch our basic video and do all the things and configure the Coral USB Accelerator for Raspberry Pi bookworm 64-bit version. Done. Now we will create our own custom object detection model which detect safety helmet. So we will create here a two class, which is the helmet or no helmet. So for that I have created new repository. I will mention the link. You need to simply copy paste the link inside web browser. YOLO11 HTTPU custom object detection. Simple. So go to the code and click on download zip, and we will download our zip format repository. As you can see, we successfully downloaded. Minimize all these things. File manager, downloads. This is what our repository. Right click, extract here, and it will extract our repository. So this is what our repository. Right click, cut, then move to the home and then just paste it. Done. So we need images. So for that we will use our USB web camera, because this is the real time helmet or no helmet class detection. So we will create our data set using our USB web camera. So I have connected the USB web camera with the Raspberry Pi 4, and then this is the img.py. So img.py which basically capture all the images for our data set. So inside repository I will first create a folder which is images. So images is the folder. Images is the folder. Inside that folder we will save all the images. Now img.py, just right click and open with the Tony Python IDE, and because we already selected our virtual environment, so we have our virtual environment already activated. So this is what the folder where we are going to save our images. So we want to change the folder path. So images, because this is the old path, images folder which we just created, right click, copy as a path and remove it from images. Remove it from images, just remove it and press Ctrl+V. It will paste our new folder path. Done. Now as I mentioned, we need two classes. One is helmet or another one is no helmet. So for each class we will create, let's just say we will create here 60 images. So 60 images is basically for helmet and 60 images is basically for no helmet. Simple. So here images, after that img is the name. So we will create a class name. So let's just say first we will go with no helmet class. Simple. So no helmet class, it will capture 60 images of no helmet using our USB web camera. This is the index number of USB web camera. Now let's just save the code, and now it will start our USB web camera, and we want to move our face in different angle. Simple. It will capture each angle images or 60 images. So let me start the code. So friends, we capture no helmet class images. So if you go in images folder, we have all the images of our no helmet class. So we have basically 60 images with no helmet. Simple. Now we will create with helmet images. So here I need to mention helmet, remove the no and helmet. Now same way, let's just save the code and run the code. It will capture 60 images of helmet class. Now simply I will wear the helmet. So friends, I have captured helmet images also. So if you again open our repository inside images folder, now we have helmet class images also. So this is what our helmet class, as you can see, with helmet image and without helmet images. Done. Now simply we will move all these images on our roboflow.com. So let me open roboflow.com. So friends, I have opened roboflow.com. Just sign up with your Gmail account, and then we will create a new project. So just click on new project. It will create a new project, and here the project name. So let's just say project name is basically YOLO11, and the annotation group. So annotation group is basically the class name. So we will mention one class which is the helmet, and another one class is basically no helmet. So I will only mention here annotation group is helmet class, helmet, and then the license CC BY 4.0, select it from here like this way, CC BY 4.0. Then the object detection, click on create public project, and it will create our project. So we created our project, as you can see. So here we want to upload our folder. So click on select folder, go to the repository and select it images folder where we have all the images, and click on upload. Here again select upload, and now as you can see friends, it's uploading all our images on our RoboFlow. So we uploaded all our images. Now click on save and continue. It will save all the images. So we successfully uploaded and we save our images. Now here we want to select start manual labeling. Click on start manual labeling, then click on assign to myself. Now we are ready, and we will click on simple start annotating. So just click on start annotating. So after click on start annotated, you can simply see this kind of window where we want to select our class. So this is basically no helmet class. So we will simply draw here a rectangle, here rectangle, and we will mention this as a no helmet. So we already mentioned the helmet, that's why by default it says the helmet. So we want to mention here no helmet class. So let's just mention no hyphen helmet and click here create class no helmet. Just click on it and it will create our no helmet class, and we have our one image saved with the no helmet class. Now go for next image. Again same way, draw the rectangle on our class, means the no helmet, draw the rectangle on the head basically. So this is no helmet, save it, then go for next image. Again same way, draw the rectangle on the head, then click on save, and it will save our no helmet class. So let me draw the no helmet class. When we have helmet class, I will start video again. So friends, we have here helmet class. As you can see, now we will same way we will draw the rectangle on our helmet, like this way, helmet. Done. And then we will select the helmet class which we already created. So helmet, and then it will save our helmet class. Simple. Now go for next image. Again we have helmet class, same way, draw the rectangle on the helmet and then simply select the class, select it and click on save. Done. So this is how I will draw the helmet and no helmet rectangle on each image as per the class. Simple. So let me first draw the rectangle. So friends, we have completed our labeling process. We successfully draw a rectangle on both helmet and no helmet class. We have done. Now let's just go here. Here you will see the name YOLO11, or in your case it may be different project name. So YOLO11, just click on it here, and then we have all the images. Now click on add 120 images to dataset. Simple. And it will add all the images, trend 120 and valid 0 and test 0. So now click on add images. Done. Now we will simply click on here version. So click on version, and then 120 images. Here it is. As you can see, it says it's we want to split the images basically. So we will edit this section, train, test and split. So just click on edit, and then here it is. As you can see, we have here options. So basically we have total 120 images. So we want to split all the images. So simply we will click on here rebalance option. Just click on it, rebalance, and then we can balance all the images. So let's just say here I will go for valid, let's just say valid 43, and then this is for the test. So test, let's just say 22. So we can move on, let's just say now train 63 and valid 35, and again I will go for 59, and now it's good. Now it's good. So train 59, valid 31 and test 30. So this is how you can split the images in between train, valid and test using this rebalance option. Now I have done with the rebalance. Now simply click on save. It will save like this way. As you can see, now we have train images which is 59, we have valid set which is 31, we have test set also the 30 images. Done. Now simply click on continue. Then here you will see final result, training set 59, validation set 31, testing set 30 images. Now simply click on continue for pre-processing. Then now again click on continue, and then create, click on create, and now our data set is ready. Here it is. As you can see, our data set is ready. Now we will open our Google Colab. So let me open first Google Colab. So friends, I have opened Google Colab. Now click on upload, browse, and then we will go in our home YOLO11 HTPU and select the .ipynb, our Colab training file. Click on open. Now it will upload our file. So we successfully uploaded our file. Now just go to the runtime, then change runtime type, and we will go with Python 3 and select T4 GPU. Click on save, and then click on connect. So we successfully connected. As you can see, now we will run our cell one by one. So let's just run first cell, then next cell, which is basically install Ultralytics. So we successfully install Ultralytics. Now let's just import our packages. So we will import our packages. So next cell is here. From Ultralytics import YOLO, from ipython.display import display and image. So let's just run the cell. Done. Now go for next cell. Now again we will cross check if the Ultralytics perfectly installed or not. So for that we will use YOLO11 n.pt nano model, because we want to work with Raspberry Pi 4, and basically we will work with our Google Coral USB accelerator. So we need nano model. So YOLO11 n.pt, and let's just run the code. It will cross check if the Ultralytics is perfectly installed or not. With the help of RoboFlow doc.jpg image, it will detect the objects from the image, and we successfully detect the object, which basically persons, car, dog and handbag. Means we have our Ultralytics perfectly installed. Now the next cell is basically for our training purpose. So we want to copy paste the code. So let's just move on our again RoboFlow page. So this is what our RoboFlow page, and then click on download dataset. Then here we will select the format. So format is basically YOLO11. From the txt select YOLO11, show download code, select it, and then let's just here there is no need to go for also train the model for label assist and all these things. Just select it, show download code, uncheck the also train and model for, and then click on continue. It will simply create the code which we want to copy paste inside our Colab file. So from this from to YOLO11, just copy as it is and open Colab file, and this is the old code from to YOLO11, which we will delete, and then press Ctrl+V. It will paste our new code. Now let's just run the cell. So we successfully run our code. We run the code and we created dataset folder, and we have now our dataset inside our dataset folder. So just click on this small folder icon. We have dataset folder. If you just click down, and then we have YOLO11. As you can see, this is what our folder, and inside that folder we have data.yml file. We have test, train and valid folder also. So data.yml, we want to mention the path for train val test. So train, click on 3 dot, copy as a path, and just go here and remove the old path, remove it, and Ctrl+V. Then valid, so val, remove the old path, and valid 3 dot, copy the new path and paste it the new path over here. Then remove the old path for test folder. Then test is here, 3 dot, then copy path, and then just paste the path inside our data.yml file, and let's just press Ctrl S and save the data.yml file. Simple. Now just close it, data.yml, and now we will start our training. So here we want to mention our data.yml file path. Data is equal to content. This is the data.yml path. So we want to mention the new path for data.yml file. So just go to the data.yml file, click on 3 dot, copy the path, and then remove the old path. Remove the old path. Simple. So we remove the old path. Now press Ctrl+V. It will paste the new path. Done. Now the epochs is 100, img size is 240, because we will work on with Google Coral USB. So we need 240 image size, which I have already mentioned. Now here we want to go with YOLO11 n.pt. So YOLO11 s.pt, remove it, mention the YOLO11 n.pt, which is the nano model, and let's just run our code. So friends, our training is started. It will take some time. Meanwhile, I will pause video. So our training is completed, friends, and our model save inside runs, detect and train folder. So just click on again this small folder icon, and then we have here runs folder. As you can see, the runs. So inside runs we have detect folder, then we have train folder, and inside that we have weights folder, and then this is what our weight base.pt. Now we want to convert this base.pt into HTPU format. So for that we will mention the base.pt path here. So base.pt 3 dot, copy the path and remove the old model, remove it, and just press in double quote, just press Ctrl plus V. It will paste the base.pt path, base.pt model path. Now we are ready and we will convert our base.pt model into HTPU format. So let's just run the cell and we will wait for conversion. So friends, we completed our process and our model is saved inside a weights folder. Base save model is the folder and the weight name is basically htpu.tflite. So again we want to click on this small folder icon. Then we have here, let's just again make like this way, scroll up and again scroll down. So detect, then train, and then we have weights folder, and inside that weights folder, as you can see, it's created base save model folder, base save model. So scroll down and then we have here our all models. So let's just search for our model, which is this one, best full integer quant htpu.tflite. At the end we have here htpu.tflite and 3 MB. So this is what our model, simple, as you can see, htpu.tflite. Now click on this 3 dot and click on download. It will download our model. So we successfully download our model. As you can see, this is what our model. Now close all these things, just close it, and we will minimize our Tony first, then go to the file manager, and then we have our downloads, and this is what our model. Right click, cut, home, and our repository, and then just paste the model here. Then right click to the model, rename, and copy the name of our model, copy it, and open Tony Python IDE, and we want to paste the model name. And this is not the file, this is img.py. So we want to open our main code. So let me open it, test.py from our repository. Click on OK, and it will open the test.py. And here it is. As you can see, I have already mentioned the name because I have already cross-checked the code. So I have already mentioned the model name, simple. So rename file, I will close it or click on OK, done. Now coco1.txt. so we want to create our label file. So again let's just open our repository and right click, new file. So we will create the text file. So coco1.txt, click on OK, right click, text editor. It will open our coco1.txt with the help of text editor, and we have here two classes. So helmet and no helmet. So let's just file, save, and minimize, close, and now we are ready and we will start our code, simple. So let's just run the code. So friends, as you can see, I have started the code, and right now there is no helmet, so it says no helmet. So, and now as you can see, this is what our helmet class. So let me remove the headphone. So friends, as I mentioned, we create our own custom object detection model with the help of RoboFlow, and we convert the model into TF-Lite format for Google Coral USB Accelerator, and we perfectly detecting the class which is helmet and no helmet. Simple. So this is basically for idea how we can use YOLO11 for custom object detection using Google Coral USB Accelerator on Raspberry Pi 4. In real scenario, you can use RoboFlow ready to use dataset as per your project. Also you can create your own dataset. The method which I have shown you with the help of img.py, you can simply create your own dataset with the help of your USB web camera. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.